Hello, good morning, good afternoon, everybody. Today I'm going to make a simple project on ANSA. ANSA is performance software for the meshing for realizing analysis under different scripts like Nastran, Abacus, the most known scripts. So today I'm going to show you to make a general introduction for the use for those who didn't use ANSA before. So it is a general presentation on the commands right here. I'll explain you these commands right here, and then we will make a simple project, a very simple project to show you how to run an analysis. So we are going to make it under Abacus. So after all, we have to make the geometry. You can make it under another software like CATIA, SolidWorks, PTC Creo, or we can make because the geometry is so simple, we are going to make it here under ANSA. So first we are going to go to File, New. So we opened a new project. Here we're going to insert some points to construct our geometry. So here, before everything, I'm going to explain a little what's this here. These comments, what do they make, the utility. So as it's very simple because the name of each command explains everything. So here topo here means you are going to make operations on geometry. Here ANSA is used when we import a geometry. We are going to prepare it for meshing. So before realizing the meshing, we have to correct the geometry. There are some errors, some surfaces that are not well connected. So we have to correct the geometry after all, because when we import CAD geometry, for example, if we have already made it on CATIA, so when we import it here on ANSA, the extension CAD part will change, so some modification will happen in the geometry. So the first step, we need to correct the geometry. Alright, so we are here, the hot points, the operations on points. We are going to insert a point, delete a point, project a point, and on another edge. Here cones, faces, and surfaces operations made. We can make on surfaces like new surface, project, uh, like here on points, project a point on another edge. If you want to offset a surface, so by practice you learn how to do that. Here curves, here points. So points here, it's not like hot points here. I will show you through this tutorial what's the difference. Here mainly hot points are used in the meshing operations, and points here are used for only for geometry, correction of the geometry. So first of all, we are going to create uh, 2 or 3 points. So we click new. We are going to give the coordinates of the points. For example, we are to put the origin 0, 0, 0. Then, for example, 10, 0, 0. Another point, for example, minus 10, 0, 0. Okay, so we can press F1 to see the view, F2, F3. Oh, the points are aligned, so we have to modify one of them. So we go to delete, for example, I'm going to delete this point, and you press the middle button of the mouse. So yes, do you really want to delete all selected? Of course. Okay, so here press new again, 0 10 0. Okay, and F1 again. That's it. We have 3 points right here. So after creating the points, we are going to create the lines between the points. So we go right here to curves, new, select the first point, the second point, we press the middle button. The middle button of the mouse means OK, means we are like enter in the keyboard. So we press it, alright, and we want to create the other line. Alright, so like I've already said, the operations that we are going to make to create a new surface, if we have already 4 points, not only 3, we have to use here the faces new and cones, fitted planar, all of them they are probably making the same function, but cones are used when the geometry have some splines, not a prismatic geometry. For our case, we have created only 3 points and 2 edges, so we're going to use surfaces, extrude, glide. So glide does the same thing like or new right here in faces, but here glide we only need two edges to create the geometry right here. You will see how. So after selecting the 2 edges, we press OK. So only the two edges are sufficient to make this rectangular geometry. We press OK. Okay, so here we have to put the property of the new geometry we created. So we press right click, new shell. So here we are going to create a shell element. What is a shell element? It's a 2D element. It's like geometry that have a very small thickness. The thickness is negligible when we compare it with the other geometries, the length and the height, for example. So we press OK, say quad elements. Yeah, we can quad elements with quad 4. Each element has 4 nodes for each element. So press OK. We press it 2 times. Here we forgot to. Here it's shadow. You can change the view from shadow to this. So if you press it, everything, the geometry shows off. We press it again, it shows up again, the geometry. The manipulation, these commands are the manipulation of the view. If you want to hide, if you want to view all, like this. So now after creating the geometry, we have to delete the points and the 2 edges that we have already created. So we go to points, delete, we select all the points, OK. The curves, we are going to delete the 2 curves, press OK. So now we only have the geometry. So we said there is a difference between points and hot points. So these are hot points, like this one, this one, this one, this one. While points here, it's like when we are going to create the geometry, the beginning. And a hot points here after making the geometry has been already made. So the second step after creating the geometry, we have to mesh it. So we have here we have square, so we go to the second function here, mesh, 2D mesh. So ANSA says unmeshed one, we have one piece, one geometry right here, and ANSA says it's unmeshed, so we have to mesh it. So ANSA is specialized, this software is specialized in meshing operations. It's very performant. I really suggest and advise you to use it while we want to make advanced meshing operations. For example, right here we are going to mesh this part. So well, we are going to give length for each element. So we select all the edges, all the elements, to press OK. So right here we are going to put the length of each element. So in the beginning we have created our geometry. This edge has a length of, I think, the beginning of 20 millimeters. So we think we are going to divide it. For example, we choose for each element length of 5 millimeters. Okay, so here the length of the edge is 10 millimeters. So when we put 5 millimeters, so he also divided the edge of 10 millimeters to 2 divided it by 2, so and each element have a length of 5 millimeters. So we are going to try again, make it smaller. So we are going to put 1. So if you put 1, so of course it will 10 divided by 1 will give us 10 divisions. 1 2 3 4 5 6 7 8 9 and 10. So everything is okay right now. We have also this function number to give us the number of elements on each edge here, 10 10 10 10. We can add, for example, if you press with the left mouse button, so it become 11, or if you want to remove one, we press with the right mouse button, so it's 10 again. So we are going to leave it 10 elements. Now here we go to the shell mesh. Here the shell mesh, for example, here if we have this little black triangle, it means there is more options, more hidden options. So we right click on mouse to show them. So no, not here. So we need to reconstruct this one. So we always have to click on reconstruct. It must be shown this red rectangle. When we do meshing operations, it must be always like this. We must press it always when we are going to make meshing. After that, the type of the elements. Here we have mixed, quad, triangle elements, and ortho triangle. Ortho triangle, like it's a quad element divided by 2 triangles. Yeah, a rectangle is made by 2 triangles. We know that. Mixed, so he will mix between the quad and the tri elements. especially needed for when the geometry is a complex one. Here we have a simple geometry, so we are going to choose quad elements even if we use mixed. So the geometry is so simple here, so he will mesh it with quad elements. We put mixed and then best select all the geometry, you press OK. So we have the geometry meshed with quad elements. So now we made a 2D element, we want to make it a 3D meshing. We are going to extrude these 2D elements to make them 3D elements. So we go here to 3D volume mesh. Here we go to, we press right button, we click offset. So offset, we are going to offset these elements. So we are already clicked on offset, so we have to select with this one. Feature area, we select all the area here. We press OK with the middle mouse button. So he wants to know the distance you are going, where the extrusion, the distance, the length of the extrusion. So let's say it's 100 millimeters, and the number of steps. So let's say 100 steps, and let's see what you're going to make. So right here we have already obtained the 3D meshed volume. So each cube right here with edge of 1 millimeters, and we have 100. So we have 100 elements on each edge. So now we are going to release it. So after we finish our mission, we have to release the elements. So to remove the geometry, we will see what does this mean. So we have press release, we select this, press OK, and now we go to delete this 2D geometry. So we press delete, select this one, OK, try again, delete. If you want to hide the geometry, so you hide the meshed part, so show, we hide it. Here the geometry, show, we hide it. So we're going to delete the original geometry. Press escape to delete the operation. So we hide it again, press delete. Okay. So now we have only the meshed part right here. So we have property, we deleted the shell element, so we have to delete the p shell property and maintain the p solid property, the 3D one. So delete. We have to compress, so after deleting everything, so we have to compress it to delete all the traces. Even if we delete something, it will leave some traces inside, so we have to delete them. So compress all decks. Okay, we go again, property right here. So we have only the default p solid property, and here are the materials. So by default, the material is steel, is the Young's modulus, the Poisson's coefficient, the density. Here we have 210 gigapascal. Here the unit is megapascal, so here it's 210,000 megapascal, the Young's modulus. Here we have the Poisson's coefficient 0.3, and the density is 7.8 E minus 9. Okay, we press OK. Alright. Here it says unmeasured, so we have to show only. We have nothing. Here, all, show all. What's the volume? Try to delete it. Okay, that's it. So here everything is okay. We have this beam with 100 millimeters length and 10 millimeters right here. So here we are now. After meshing the part, we are going to put the boundary conditions, the forces applied on the element. It's like we are going to make a static analysis. So we are going to, if you want to use the abacus script, press abacus. For example, if we want to constrain, we don't want it to move here in the first 2 millimeters, 2 elements right here. So we go to boundary nodes. With this command, you are going to select this, 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 and press OK. So all the nodes right here, and also the same thing in the other extremity. Okay, so we chose the nodes here. We press OK again. So the boundary here. So the DOF degrees of freedom 1, 2, 3, 4, 5, 6, 6. So 1 through 3 it's for translate displacements, and the 1 for the x-axis, 2 for the y-axis, 3 for the z-axis, 4, 5, and 6 are the rotations. 4 rotation beyond the x-axis, 5 the y-axis, and 6 the z-axis. So we are going to constrain. So if we have 1, 2, 3, 4, 5, 6, we are already constrained all the degrees of freedom. If we want, for example, constrained only on the displacement on the x-axis, we delete all the others and we leave one. In our case, we need to constrain it on all the axes. So 1, 2, 3, 4, 5, 6. Here, operations say it's a new operation step. Say 1. By default, we put 1 here. And we press here. For example, if you want to give a name, we say fix it. Press OK, and we show it. So here the nodes that we have already selected are fixed. These nodes doesn't move. So now we want to apply a force or a pressure on the upside of the beam, for example. So We don't have to select all the nodes right here to apply the forces. We can use this function, this coupling. We are going to make a coupling between all the nodes that here on the upside of the beam. So we select area all the nodes of the upside. You press OK. So we have 1111 nodes here that you see on all this side. We press OK again. We want to create a master node. This master node will, is going to join all these nodes. So you will see, we press, it's the center of gravity, we can change it. Let's press next. So all these nodes are coupled in one node, this node. So if you want to apply a force on the up surface of this beam, so you need only to apply the force or the pressure only on this node, and by default it will be applied on all this surface. Finish. It's distributing. Finish. It like this. Now we are going to apply the force. So we go to C load node. We press this node. This node right here. And we press OK. So here, like usual, new step 1. Here the force is going to be applied in our case on the y-axis. So here we have to choose Fy and the magnitude in newtons. So the force in our case, let's say it's 500 newton. We can give it a name, force. Okay, load. So you see this arrow means we have already applied the force. So now we have just the last step is the post-processing to view the results. So before we have to check that the material is already defined. Okay, we can make a quick check, abacus checks, execute. So here this master doesn't matter, so all are checked in green, so everything is okay. And now we have to final compress, like I said before. We have to remove all the traces of any deleted parts. So okay, now we have to save it, output, abacus, or in our case now I'm going to use abacus viewer, the post processor of abacus. You can use the meta post processor of ANSA is the preprocessor, and meta post is the most processor. I'm going to use abacus view. So you give it the name tutorial, and we'll save it in here in temp. So this directory temp when you have already installed abacus on your PC, so it will be automatically created. So now I am going to open abacus viewer. So abacus command and abacus viewer. So save tutorial point input, save it in this folder, save it here. By default we put none, here all, and here we don't need this. It will affect the size of our document, so we don't need them. Press OK. Here the output format, in my case I'm going to use Abacus 6.14. It depends on your version of Abacus you are installed. So press OK. Output completed. So now we have to run the analysis. Here, so C 2.temp is the folder where everything is going to be saved after running the analysis. So here the command of Abacus to run it is Abacus, the version of it 640 space G equal and the name. We have already named it tutorial, so we put tutorial. We press enter. Where did I save it? So C temp tutorial. Well, I didn't save it in this folder, so I'm going again to save it. I can see. Tutorial, why I didn't find it? So I'll try to save it again. Output Abacus tutorial. Save it. Same here and OK. That's it. It's tutorial point input. Now tutorial, we press OK. Oh, what? So again, the analysis is running right now. So we have to wait it. We are entering the calculation. So here, if we have this star, we open it. It says the analysis has completed successfully. So cheers, everything is alright. So here, after running the analysis, it generates all these files. So this points that gives you a general information or about what's already happening here. If there is any errors, we have to correct them, anything like that. So we go to the post processor. We are C10, the ODB file tutorial. Where is it? This one. Okay. So like you see right here, minimize the speed of the view. That's it. So the force applied on all this one On the fixed, we have the fixed here. So we have the maximum force of 62 megapascal. So it's very lower than the limit of elasticity of the material, which is 240 for the steel, 240 megapascal. So everything is right. So thank you for watching. I hope that you have enjoyed and learned some new things about ANSA. Thank you very much.